Lesson 7.6 is on function operations. We're going to add, subtract, multiply, and divide functions. We're also going to find the composite of two functions. So let's take a look at this. Let's keep in mind that functions are, remember when we did the function machines, we put in some x value and out would come some y value. So we can add those functions together. So f plus g of x is just f of x plus g of x. Multiplication, f times g of x is just f times f of x times g of x. Subtraction, f minus g of x is just f of x minus g of x. So far, this is pretty straightforward. And f divided by g of x is just f of x divided by g of x. And look at this one restriction. So g of x, this function can't be equal to 0 because we can't divide by 0. That would make it undefined. So let's take a look at an example. We have two functions. We've got f of x, which is negative 2x plus 6, and g of x, which is 5x minus 7. And we want to find, first of all, f plus g of x, and then f minus g. So f plus g is just going to be f of x plus g of x. So let's look up here. F of x is negative 2x plus 6. We're going to add g of x. Okay, so this is just a simple algebra problem. We're just going to combine our like terms, remove the parentheses. In this case, we don't have to worry about distributing a negative or anything. So it's just going to be negative 2x plus 6 plus 5x minus 7. If we combine like terms, negative 2x plus 5x is 3x, and 6 minus 7 is minus 1. So that's our composite function. We added these two functions together, and this is the function we get. Let's look at f minus g. All right, so this is just f of x minus g of x. Once again, f of x is this thing, and I'm using parentheses here for a reason, not just for fun, because I want to make sure that I don't lose track of any minus signs. So minus 5x minus 7. Okay, we're just going to add up like terms, but we need to get rid of the parentheses. So this becomes negative 2x plus 6. We're going to distribute the negative 1. So we get minus 5x plus 7. And now let's combine like terms. Negative 2x minus 5x is negative 7x. And 6 plus 7 is plus 13. So that's f minus g of x. All right, so the domains of f and g are f plus g and f minus g. The domain is what x values can we put in. And sometimes we can't always put in every value of x. In this case, there's no denominator that we have to worry about being 0. So the domains for both of these are the set of real numbers. All right, let's look at what multiplying looks like. So this time we want f times g of x. So this is just going to be f of x times g of x. Here's our f of x this time. It's x squared plus 1. And g of x is x to the 4th minus 1. Okay, we need to FOIL these. So x squared times x to the 4th is x to the 6th. X squared times negative 1 is negative x squared. 1 times x to the 4th is x to the 4th. And finally, 1 times negative 1 is minus 1. I'm just going to put this in standard form. Remember, that's the biggest exponent to the smallest exponent. So first comes x to the 6th plus x to the fourth minus x squared minus 1. And that's the answer. Oops, sorry about that. For f of x times g of x. Let's look at f divided by g. So that just means f of x divided by g of x. F of x is x squared plus 1. And g of x is x to the fourth minus 1. All right, hopefully some of you have realized that this x to the fourth is actually a difference of squares. X to the fourth is really x squared, and 1 is really 1 squared. So I can split up that denominator into x squared plus 1 and x squared minus 1. If you FOIL these, you'll get that. And lo and behold, we have an x squared plus 1 up here and an x squared plus 1 down here. So those go away, and this just becomes 1 up here. So our final answer is 1 divided by x squared minus 1. Let's look at the domains. So remember, the domains are, we need to think about what x values could we put in there. The domains for each of these individually are the set of real numbers. And so that means that the domain for this is also the set of all real numbers. But the f of x divided by g of x, we need to make sure that this denominator does not equal 0. So x squared minus 1 can't be 0. Well, if we solve this for x squared can't be 1, which means that x can't be negative 1, and it can't be 1. Because if it was negative 1 and we squared negative 1, that would be equal to 1. If it was 1 and we squared it, that would be equal to 1. So the domain of this one can't be negative 1 or 1 because g of 1 and g of negative 1 is 0. All right, try the quick checks for these two. The first ones are adding and subtracting, and the second ones are multiplying and dividing. All right, let's talk about composite functions. So a composite function, we're going to actually put one function into another one. We're going to solve the first one that's on the inside, get an answer, and then put that answer back in. So let's look at a real-world example. So a store offers a 20% discount on all items, and you also have a coupon that's worth $3. So we're going to use these functions to model discounting the item by 20% and applying the coupon. So the first function, here's the price of our item. If we subtract 20%, this is really 1x minus 0.2x, so we get 0.8x. And then this is, we take the price and we just subtract $3 because that's the coupon. So here's our two functions. All right, let's use a composition of the two functions to model how you would pay for an item if the clerk applies the discount first and then the coupon. So the discount first means that we're going to use this f of x first. So that means g composite f of x. And this is different than when we just did multiplying. This is an open circle. It means g composited with f. So we're going to work our way from the inside out. First, we're going to do f of x, and then we're going to do g of x. So let's figure out first what f of x is. Well, f of x is 0.8x. So this is what's going to go in here. So this now becomes g of 0.8x. So that means that in this g function, anywhere where there's an x, see this x, instead I'm going to put 0.8x. So this becomes, oh, there's an x right here, so instead I'm going to substitute 0.8x. and then minus 3. So all I did was replace every x here with this f of x. So that's what it looks like if we composite g composited with f. Let's take a look at what happens if we apply the coupon first and then the discount. So this is the opposite. This time, we're going to deal with g of x first and then plug it into f of x. So let's remind ourselves. So f of x is 0.8x and g of x is x minus 3. So this time, we're going to deal with g of x first. Well, g of x is x minus 3. So this thing is going to become f of x minus 3. That means everywhere in f of x where there's an x, we're going to replace it with this. So this becomes 0.8 times, well, what was x before is now x minus 3. And if we distribute this, we get 0.8x minus 2.4. There are several problems on your homework, and we'll do one in class that uses this composite so that you can understand it a little bit more.